Sandeep Gupta doesn't need introduction, right? He's a chair of our systems side. We also so the next part of the program is that they're going to have a conversation. He's going to start talking about a bunch of things, technical, and get a glimpse of the journey that they've taken. Particularly Mel has taken, at USC, and the kind of lessons that inspires us. And I'm sure you'll have a chance to also ask questions. After that, we'll have a reception. It's a special reception. We're going to we're creating this wall of pioneers with plaques, and we're going to unveil the ones so far. So stay for the reception. So Sandeep, take it over.
Thank you. So I wanted to start with a reading of the Mel's biography from the website. Since nobody visits our website, I thought I'd not. But I wanted to start with a an alternative biography of Mel Breuer that I'm going to touch on some of the snippets, less controversial ones. I'll leave the controversial ones for him to mention. So Mel Breuer is born and brought up in Los Angeles. He's lived here for a very long time, much longer than many of us. Even before he had any connection to USC, he lived in this area. He lived towards the ending, last few years of Second World War. He lived, today I verified with him, 36th and Vermont, literally, Smart and Final, somewhere behind Smart and Final on 36th Street here. When the war ended, the boys came home from the war. The landlord evicted them because they were renting the place and because their son came back from war and needed the apartment. So Mel actually lived not too far from this campus. But then he got misguided. He went to UCLA, got his undergraduate degree, got his master's degree. And this is master's degree in a time when, logic was not a subject of study in electrical engineering. It was not even a subject of study in mathematics. It was a subject of study in philosophy. So Mel studied, I think that was one of the last courses he took as a master's program, in the one of the courses he took in master's program, and he always talked about philosophy. And I'm always grateful that he didn't make me study philosophy using Aristotelian terminology, because that drives me crazy. I just can't get Aristotle's logic. Mel went to Berkeley after that. He got his PhD there. And the most shocking thing to me about Mel at Berkeley was, one time we were having lunch, and I asked him, I said, Mel, you were at Berkeley when free speech movement started. And Mel said, yeah. It was going on somewhere over there. I said, did you participate in it? He said, no, maybe one time when I heard about it out in the newspapers, maybe I went to take a look. So Mel never even participated in the free speech movement, even when it was going on and things. And so the Mel then decided to join USC. But so by the way, everything that I'm going to say today is based on personal conversations and memory, this thing. So everything is true as I remember it. Okay, it's true only modulo of my memory, and so I should start with a disclaimer. A radio program that I sometimes listen to called Moth on public radio. They have stories by people, and they have this. At the end, they always say that all our stories are true and remembered by the narrators. So this is the standard of truth I'm going to apply to today, use today. So then Mel told me a story that just before he joined USC, you took a trip overseas, and when he came back to LA, didn't even have $1 in the pocket when he came back to LA from the trip. You remember that, Mel?
The dollar, yes.
So Mel joined USC, and that's where I want to start our conversation. One other thing that I'd like to point out, and I have this in slides, but I thought I'll just do show and tell. A few years ago at a conference, we had a day-long workshop to talk about Mel Breuer's impact on the field and so on and so forth. And one of our colleagues who will come up in our conversation soon, John Hayes, who used to be on the faculty here at USC, he did his 15-minute presentation. And the point of the presentation was that Mel looked like this when he was born. Mel looked like this when he went to college. Mel looked like this when he joined USC. And Mel looked like this when he this thing. And Mel would look like this, 40 years from then. And the reason for that joke was that for 20 years, in all the journal publications, Mel used the same picture. So with that, I want to start with something which is a little bit about USC, but particularly this is actually a hard document to find on the website. Mel did a few years ago when Masood was the CNG director. He convinced Mel to spend time to write a history of computer engineering at USC. And Mel spent a lot of time writing the history of computer engineering at USC. And I can't say it's the history of the computer engineering group because this is really the sort of the mother sauce from which computer science and other things have forked off at USC. So I wanted to basically sort of use this document here, and you can find it if you search for history computer engineering, and then you search it on cng.usc.edu, then you'll be able to find this document. But there's no link to it. So Mel, tell us what USC was like when you came here.
All of USC or engineering?
Engineering.
Well, computer-wise, it was minimal.
Mm-hmm.
Okay. We had Assistant Professor Bob McGee, George Becky, Irving Reed, and that was about it.
Now, you said Irving Reed, but Irving Reed was a computer engineer.
Was a what?
Was a computer engineering guy at that time.
Yeah.
So many people here might not know this. Irving Reed went on to do, of course, a lot of work in coding theory and Reed Solomon and Reed Muller and other codes and so on and so forth. But he was in the computer engineering part of the faculty here.
Right.
When you came here in '65.
Right.
And then you started to recruit after you joined the recruitment effort.
Yeah, I was the department chair. It was Zorad Kaprelian, who became dean, etc. Saw me as the senior guy, not because of my accomplishments, but because everybody else was busy doing other things. And he essentially gave me the authority to recruit. And so I went out and recruited people. And in fact, most of the people in computer engineering, even today, I recruited.
So start with the Seymour Ginsburg. Who are the people you recruited early on?
Well, I should have reviewed my notes. Well, Dave Russell, who's now a professor at MIT, and Ginsburg, you mentioned, Horowitz, Ellis Horowitz, Art Friedman, John Hayes. I don't know. But most of them, Masood, I recruited you, Prasanna,
Prasanna is waving his hand.
Burrell.
Birel could not synchronize his clock. He had to leave. Birel could not synchronize the clock. He had to leave. He's here?
He just rerouted himself.
So in the history you write about sort of the a lot of recruitment. Some people, of course, stayed for a long time. Seymour Ginsburg stayed here until he retired. John Hayes is now a professor at Michigan. He stayed here for better part of 7-8 years, something like that.
Yeah, quite a bit.
Quite a while. While Art Friedman was here for a long time before he moved back east. Becky, of course, is still associated with USC. Alice Horowitz is still here, and so on.
Alice Parker,
Alice Parker.
my recruit.
That was much later, not in the early years.
Right, later.
Before us.
Before us.
Yeah.
But tell us a little bit about how the computer engineering and the computer science sort of emerged from there, and sort of different ways in which people sort of move between these two departments, two different parts of the whole.
Well, computer science, we started as a computer engineering program, and it was together with math and electrical engineering. Ed Blum represented the math part. Then computer science got more popular and the area, and the faculty who thought they were computer scientists, even though there wasn't a department, thought they should become a department, and they wanted to hire Per Bridge Hansen, who's a very well-known compiler guy, and he was at Caltech, and he wouldn't come unless we formed a department, and he'd become department chair. So there was some politics there, which I wasn't part of. Anyway, so they formed a department, and some of the faculty were given the option. Like I was, do I want to be in computer science or EE? So I chose EE. Horowitz chose computer science. Yeah, and Becky chose EE. Interesting enough, even though he ended up being a chair of computer science. And so the split occurred naturally. Okay, and I don't know what to say about. There are very few problems. Some people later wanted to go from EE to computer science. Okay, and so that move came about. Other than that, it's been.
So the later moves you're talking about are the robotics group and the AI groups that moved from
EE. Like EE. George Becky went over there and brought Navatia and some other guys. But politics-wise, I don't think there's been any issues.
So, in terms of basically the style of, in the early days, I mean, you worked with Zorab Kaprillian when he was a chair, before he became the
provost,
the dean and the provost, and after that the provost. Everybody has interesting stories about Zorab. You got to have some interesting stories about Zorab from the old days.
I'm not sure how interested it is, but it's the only one I have. I remember I had a ONR grant, and George Trimble was the PI, and Zorab.
The program manager, you mean?
The program
manager.
Program manager. I was the PI, and Zorab took the three of us to lunch one time, and in the middle of the conversation, he says, Mel, what is so good about this ONR grant is that it's 5-year renewable. Okay, and he was looking at Trimble all this time, not me. Okay. And essentially, that was the way Zorab did business. He essentially told people what he expected. And
that's the story I was talking about. So the research that I mean, just turning a little bit to sort of your research, I actually went back and looked at, these days you search for things. And it's interesting pattern, actually. This is really how the discipline has changed. And I'd like you to comment on your own experience. And as I chronologically ordered Mel's papers, until 1970, mid-70s, for first 10 years, all the papers are single author papers.
Oh.
The second author starts to appear after that. I mean, so sort of give us a sense for those of us who have written very few single author papers. Give us a sense about how the research changed basically during that time, and how much of that was basically sort of universal, and how much of that was specific to the conditions at USC or in your group.
I don't know. Maybe Bob can confirm or answer that, but I think when we first came in the 70s, 60s, it was assumed that you would have single-authored papers. And
it was not only assumed, we didn't have enough PhD students to do all the ideas that we had.
Mm-hmm.
At least I was in that situation. I don't know about you. I don't remember having more than 1 or 2 PhD students for the first 8 or 10 years that I was here.
Mm-hmm.
So is that because the first student authors that I recognize here are Pratima Agrawal, Abramovici, and Quinn, whom I have never met. Quinn was a student.
Neil Quinn. Yeah.
So those are the first two of whom I know very well, but the third one I do not recognize. But those are the first student authors. There are a couple of other colleagues who appear as co-authors in the first few years, but really the first 3 students I see. So is that accurate? Were they your early students? Some of the earlier students?
Well, they were earlier students, but they weren't the earliest. Danny Ko and Chang were some of the earlier ones. Mm-hmm. But I guess we didn't publish immediately. Mm-hmm. Plus, I spent a lot of time on these books.
Okay.
And so I was very book conscious. But I do remember the pressure of having single author papers.
I mean, even as late as when I came up for tenure, I remember Ed McCluskey pulled me aside and he said, I received a letter of request for your promotion. Bob must have contacted you. And he said, you guys don't write any single author papers. It's very difficult to write a letter of recommendation. And for the next 3 months, I was quite tense about what he had written because Ed McCluskey so even the old timers basically try to apply that standard on some of the junior people. So the overhang, I'm assuming Ed McCluskey wrote a good letter for me, but I remember Ed pulling me aside in 95, 96, and telling me about that. So you talked about the books. I brought 2 of your books that I'm more, very familiar with, one more than other. And I wanted to take a little bit of time to sort of also discuss, because I want to understand and share with especially the junior people in the room, sort of the thought process, what existed before this in the field, how the field basically sort of, what was the motivation behind the books, what were the circumstances that led to the writing of these books, and so on and so forth. So this is basically, so by the way, there are going to be questions from this book for everybody here, especially the students. Some of the problems, if you didn't do from the slides, we'll talk about that. But this is this is the design, one of the earliest books in design automation. Can you talk about really how this book came about? And
yes, there's the design automation group, of the IEEE, and in those days, design automation was, when I first came, design automation was a very small area, okay? And in fact, there was only one tenured faculty that they could get a letter on me. That was Don Dietmeyer. Do you remember? You know, DDL, Digital Design Line. Anyway, so the field was very small, and most of the people knew each other. Okay, it's not like today. There's 1,000 people at conferences, and they had workshops. Okay, and I was part of this workshop, and the workshop was mainly IBM people, because IBM had the largest design automation group, in the world. And they were talking about trying to get more students interested in this thing. And they said, let's write a book, okay? And they all volunteered to write chapters. And I was one of the few academics in the room. So I was elected to be editor-in-chief. And so that's how this book came about. Guys from industry wanting to get young, new people into this area. And, in fact, J. Paul Roth, who's very famous in our area, was supposed to write the set chapter on synthesis, and he bowed out. I ended up writing the chapter on synthesis. So that's how this book.
That's how this book came about.
Yeah.
And so this was the first book.
That's, yes, to the best of my knowledge. This is the first book.
The first book in design automation. The courses on design automation, did they start right after this? They were already there before this? I mean, at USC and other places?
Other places didn't have
courses.
No. And I don't know if this course, the course here has been here for a long time. Okay. 50 years.
And we'll give the students this book so they can figure out whether the courses are still in the similar form based on correlating this with your slides.
Yeah.
There's an interesting story behind your other book, the testing book also.
There is. Oh, yeah. I'm not sure interesting is the right word, but there's a story that essentially the Weizmann Institute in Israel contacted me to put on a 2-week short course in design automation. And for this, I was in charge of the test part, okay, and other people, Hannon and the other authors of this book were in charge of the other parts. And so I had written up an extensive series of notes on testing. And then Art Friedman came to USC, and Art is a book publisher, among other things, or was a book publisher. And he said, let's turn this into a book. Okay.
Yeah, the Computer Science Press was Art Friedman's wife's family.
Well, his family. Yeah.
His family, okay.
Anyway, so we turned those notes into a book. And that became very popular.
Which was the first book on that subject?
Well, the Menon and...
They had a switching theory book, but not a...
No, they had a test book.
They had a test book?
Yeah.
Okay. So I was misinformed. So working with the students must have been different in the days when there were few students, compared to basically now when faculty members have, 5, 10, 15, 20, 30. Some of our colleagues have 40 students. Can you... Huh? How was the experience of working with the students different back then? You've had big groups and you've had small groups. Sort of, can you self-calibrate your experiences in working with the students over the different eras?
Well, it was when you had big groups, you had lots of money, and and that made life easier. Plus, you could do long-range projects like implement stuff, and which you couldn't do with a small NSF grant. But the interaction is I don't see any big difference between how I interact with students. I used to yell at them. I still yell at them.
You and me both, Mel. I have to sign a disclosure with all my students saying that I only bark, I don't bite. And that usually modifies them. So I have to, sort of, before I jump into some couple of technical things that I wanted to kind of discuss with you and connect it back, I would like to basically sort of take a moment to describe the first time I saw Mel Breuer. I believe, as I said, it was this paper being presented at a conference. And it was a paper from somebody who had spent a lot of years at IBM, was very well respected in the field of CAD, especially for implementing really industry-grade code and CAD tools. And the paper had a lot of buzz because it had accelerated certain CAD tools by significant amounts. And Mel Breuer stands up and he says, "John, that was a great paper, but I didn't get a sense of the big ideas that made this acceleration possible. It's good that it's faster and better. I didn't get a sense of what the main ideas are that made it better and faster." And John, ever practical, he said, "Well, it's just very good implementations." And so Mel goes back and says, "But there must be some algorithmic enhancements. If there are no big ideas, at least some algorithmic enhancements." And John, "No, the algorithms are more or less the same. So there must be some new data structures that make this better." And John looks at Mel and says, "No, data structures are more or less the same." And it went on in that way, and I don't remember the whole conversation after that. And so that's the first time I saw Mel Breuer, and a few months later, I get an interview call. This was in fall of 90 and spring of 91. I get an interview call. Mel Breuer invites me here, and my advisor says, "Oh, be careful. Mel is tough." He said, "I've seen that. I saw that. Be prepared for anything." So I said, "Okay." And I came here, and Mel sees me and he says, "So what's your presentation on?" I say, "This topic." He said, No, I was hoping you'll make presentation on this other topic." This is before we didn't have slide decks ready for all of these things. Unlike today, if you basically have a conference publication, you basically probably have already a good set of slide decks and things like that. So he said, "But okay, it's okay. Tomorrow you can come to my group meeting and give a talk on this other topic." So I said, "But I don't have the slides." He said, "No problem." He gives me transparencies, a box of transparencies and colored pens, and he says, "Just make the transparencies tonight." So that's how it went. So next the morning, next day at lunch, I made a presentation. And this is where I want to basically share. So when I get an offer from USC, my advisor again told me, he says, "Mel Breuer is tough. Remember this thing at ITC with John, the series of questions?" And I had to spend a lot of time thinking about how I process this. What was, sort of Mel's motivation for going after this guy with question after question after question. I mean, most people I know would have perhaps left him alone after the first and second try. And I came to an answer came to me. This is sort of my personal reflection here. Answer came to me. It says he couldn't have gone back 5 times back in a public forum with questions if he had any malice. this was really Mel trying to understand what was going on. And on that, I basically decided to take the offer here and came here. And I'm really glad that we had 25 years of wonderful collaboration after that. And I have never seen, and I think I made the right judgment of that incident, right analysis of that situation. And that has been basically my experience on this. I don't know if you remember that conversation.
Yeah, I remember. I didn't know you were there, but I remember asking those questions.
So
I was a little bit more direct than you in that I think I said, like, everything you've said has been known already.
Yes.
Okay,
Yes.
has been published already.
Yes.
So what was it that you did that
is new.
that was new?
So I deleted the preface. So that's the first time I met Mel Breuer, and there are many other stories that I could share, but I wanted to go back to sort of the technical part a little bit, just for a few minutes, and sort of understand. One of the things that you mentioned today in your presentation was basically that, about placement. Over the early on, you basically did a lot of work in different areas of design automation. But last 25 years, you sort of left some of that physical stuff behind, and you concentrated more on the test side. But I want to go back to sort of one of the things that actually gets you mentioned again and again in various citations for your various awards, is this thing about the force-directed work of placement and other things. So I want to basically sort of connect it to some of the things you're talking about, because in one of your slides you showed these modules with wires between them, and you mentioned rubber band. So take it from there.
Well, I mentioned the min-cut placement that is very popular. Another that we did with Quinn was the force vector.
This paper is so old that IEEE online shows it well, but it doesn't print it. Print it very nicely. It just cuts it off.
Anyway, so that model was based on essentially objects that are connected together should come close to each other, and therefore we put a spring in the model. Okay, and objects that are far apart should repel each other. I mean, the objects that are not connected should repel each other. And then we did a lot of other heuristic type things, such as, well, essentially we modeled the placement problem as a astronomical type thing with a center of gravity and can't remember some of the others.
Forces on all objects would be zero, right?
Yeah. And essentially, we essentially let the system go, okay, and it vibrated, and so we put resistance in there, and all sorts of things like that until we got a placement, and that turned out to be a whole new class of placement. So the min-cut. This was based on distance, and min-cut's based on signals cut. And
and the state-of-the-art placement today, coming out of commercial CAD companies, is based on force-directed placement.
What was the end?
Yes, in commercial tools today, state-of-the-art still use the force-directed paradigm.
I thought they all used min-cut.
No, min-cut is sort of the fast optimizer, and they combine min-cut with force-directed.
Oh, okay.
But the basic mathematical engine that's used formulation is force-directed.
Okay.
For the global placement.
So that same question, Mel. So when you were doing this work, obviously there was no prior work in CAD that you could say here is a reference paper and sort of built on top of it. So what was your motivation for sort of coming up with these kinds of things where there is no precedent in the domain at all?
Well, that's not true. There were references. There was.
I couldn't print them, but they are there.
Yeah, yeah. No, there was previous work on all these problems.
But this previous work, why was this considered the? I mean, in a sense, this has broken new ground, right? And so,
Yeah, well, the min cut was definitely new information. No one had ever thought of a non-distance type thing. So that the whole concept was brand new, and the technique ended up working well. As far as the other things, I mean, you get a PhD student, and you say, "Here's force directed," and people were using springs and things like that before. So he just went further and took it deeper.
So maybe I think we should, the other senior faculty here, research built on top of a big body of work versus sort of a smaller body of work. I mean, how do you sort of generally opening it up to other senior colleagues? So I'm just trying to redirect Murli's question to other senior people here. How do you sort of see the difference in eras when your work was built on perhaps a handful of references? Andy, Bob, Jerry, compared to basically today when we basically face students in their PhD dissertations have 200 references, 250 references. Career award proposals literally have 200 plus references today. How do you sort of see the difference? I mean, I'm just turning Murli's question to other senior people who have the luxury of having worked when there were 3, 4, 5 references.
I try to avoid the area that already has 300 or 400 references. It doesn't seem like a place where you can make an impact. You might be able to make an incremental improvement of some sort.
Jerry?
Well, in my case, some of it was luck. I mean, you get good students, and all of a sudden they push you in a new direction, and there isn't much that they have to read.
You mentioned that in the Lokizade about paper with no references.
Yeah, really luck.
Mm-hmm. Andy?
Well, of course, years ago it was much difficult to find references. You had to go to indices and go out and pull out the journal off the dusty shelf. Of course, things are totally different now. Often you would get a lot of information just by talking to people at conferences.
Mm-hmm.
And seeing what they're doing, getting references directly from them.
Mm-hmm.
And again, as Jerry and Bob said, you always try to do something new, which there were very few references. Because that simplified your literature search.
So let me get to some more recent, one more research topic I want to hit. 15 years ago, you started talking about really this, came up with this idea which seemed, trying to use these, that there is value in some of the chips that are being thrown as being faulty chips. And you told me a story, and it came out actually in a conversation we had at TI Research. Mel and I were there together, and Mel was pitching this. And suddenly, from nowhere, Mel starts describing what his father used to do. You want to share with us what your father used to do and how this idea of using bad chips you tried to sell to TI Research? You remember that incident?
No.
So Mel's father had a junkyard.
Yeah.
Salvage yard in LA. I don't remember. So you want to?
Oh. Well, I'm not sure I'm getting to the story you want, but it's essentially during World War II and afterward, they weren't making automobile parts for cars. Everything went toward the war years. And so cars still got in crashes and were sent to a junkyard. My dad was essentially a components guy. He was interested in brake shoes and clutch plates. Those days they didn't have automatic transmissions. Okay, so cars had clutches and clutch plates and water pumps and things like that. And he would collect, essentially, he would buy all these parts from the junkyard and then sort them, all the water pumps here. And it would go to a water pump rebuilder, okay, who would essentially rebuild these pumps and sell them as used, parts. But is that the story?
Yeah, that's the story.
Oh, okay.
So we were at Texas Instruments. Mel doesn't remember this, but we were at TI and we were trying to pitch this idea. And TI people got very hung up for reasons that I understood only later, a few months later. They got very hung up on essentially creating. So if you had bad chips, but they were functionally quite good, in the sense that some of the ones and zeros were not exactly correct, but really, if you look at the image quality or whatever, it was good. It was equally good. But they got very hung up on reputation and having another part number in inventory and so on and so forth. And Mel suddenly jumped up and he said, "If you guys don't want to sell these, I'm son of a junkyard. My father used to run a salvage yard. And I will come and I will pick up these from your reject barrels. And I will take all of these chips. And I will not put TI names on these chips. I will put my name on the chips and I'll sell the good ones. You want to make a deal on this one?" And that actually moved us to the next level of meeting at TI. Unfortunately, I said something crazy when we went to Houston in the following meeting that caused the whole conversation to end, but that's a different story. But that actually got us a meeting at a product group. So the research people actually were convinced by Mel's sort of challenge to them. And they actually arranged for us to meet with one of their product groups at Houston. And that went very well until literally 2 minutes before the end of the meeting. I opened my mouth and said something, and the music stopped, and that project just disappeared. Literally, check was in our hand and it disappeared. But that was my fault. So you talked about the history of design automation, and you said that we.
So what did you say?
Huh?
That was
It was a technical thing. It was not particularly interesting. The fact that it had such a dramatic turn, I raised the issue of burn-in, and I said, if these chips have some failures, then there's a probability that failure will cause the chip to continue to fail. And we need to figure out how to basically sort of screen for those things. So things may have failed in an acceptable way today, but a few months later, there may be a latent mechanical problem with the chip, and that may cause the failure to become much worse later. And I mentioned the issue of burn-in, and the music stopped. They said, "We don't do burn-in. TI has banned burn-in, and this shall never fly." And they literally showed us the door. And when I drove in silence, and Houston airport is far away from where TI is. So it was a technical point I raised. In full disclosure, I think that day I learned the perils of full disclosure. But you learn and you move on. We got funded. Keith is here. Antonio, I guess, is not here because he's on sabbatical. 4 of us then got funded by NSF a year later. So the project did go somewhere, but that portion of the thing never went anywhere. So Mel, you talked about the past of design automation. You talked about, you said there are those areas where there is sort of, how much time we have? We should wrap up? Okay. So maybe let me change gears. You want to share something about your time as department chair, because sort of you were the de facto chair when you were young because the others were busy. but then you were actually department chair, and you sort of flanked two, Bob's.
I was in between.
Yeah,
those
you
two.
flanked on both sides. You were sort of the before and after Bob. So and Jerry. So I think and Sandy. I mean, we have all the chairs in this room, for as far as I can remember.
I was trying to remember something that Mel said, and I can't remember it. So maybe Mel can. And this was at the department retreat. I think it was up in Arrowhead.
Yeah.
And they had a panel with the chair.
Yes.
Jerry was on it, and Mel.
Bill was on it. Bill was on it.
The electrophysics chair was on it. And everything was going along smoothly. And then Mel challenged everything we said, I think. And I can't remember what exactly caused that. Do you remember the event? Yeah?
Sure, I remember the event.
So what was the challenge, the issue you raised?
Well, I think there were a lot of them. One of them was that department chairs have no discretionary funds.
Discretionary
funds. And the other was that I remember getting a memo. We all got a memo on being collegiate or some word like that. And collegial. And I don't know. I made a lot of controversial comments.
So, in terms of basically the department chair, sort of in addition to recruiting people, what are the other things that you basically think you enjoyed about being a department chair?
Enjoy.
That's the wrong word to use.
Don't I know it?
How about tolerated?
I'm not sure there's enjoyable things. Mo, do you remember any of my controversial comments from Arrowhead? Anyway, no, I don't think there's any.
We just remember the good things.
So,
I actually went through a file, and I was remembering that when I was chair from 84 to 91, and then you became chair, it was almost like biblical in the following sense. I had the 7 fat years, and then you came in to the absolute lean years. It was really bad. How lean? I found a memo that you sent to us.
about the phone lines in the conference room?
The title of this memo is Postage, Telephone, and Copy Costs.
Yeah, I remember this.
This could have get published, in an IEEE transaction. It's so detailed. Not only did you tell us how to save money on telephone charges, mail, express mail, fax, and copying, but under copying you had 5 different categories. One of which was blue books. Yes, Mel recommended that students who take more than one exam do it in pencil, and they erase their answers from the first test. No, I'm just joking. But you did have a category on blue books in there, which was rather amazing. And then what I didn't realize until I turned this thing over is that you had prepared a table showing all of us and what we were spending on copying. Yeah. Bob,
Things were hard.
Back then, it shows.
We had 0 raises.
You were cheap, $48. Wait a minute, is Jay quote here? Jay was the all-time big spender. According to this, Jay spent $505.
In photocopy.
Yeah. So, but actually,
What was Brewer's number? Is he on the
he probably wasn't teaching. No, I don't see Brewer. No.
Fetch the table, huh?
Actually, you were $190. Anyway, yeah, you inherited some pretty tough times. Wasn't easy, but you did a good job.
Okay.
Yeah. I mean,
We went us through these 3 days of a course taught by some outsider about how to market ourselves, right? As a department to our customers, clients.
Yeah.
Right?
Who's
Lots of
come up with a strategic plan.
right, also free.
so
I could just say one thing, having been sandwiched between Brewer and Brewer. When Bob was department chairman, he came home one day and he looked at me and he said, when I get finished with, I'm not telling you, he never told me anything that went on. When I get finished, you can write a soap opera. That's what he told me.
I actually have seen Sandy's drafts.
Have you writing already? I have thought about it.
Sandy actually has notes. Sandy's he's an incorrigible note taker. He has notes.
I can imagine so.
So we should this thing. Mel, you want to say anything in there so we can close? Any wisdom to share? Any thoughts to share?
Take the CAD course.